Okay, so now, here it is. Week 4's homework is just one page. It's called Week 4 Written Excel. It's both written Excel on one page. Let me show you. At the top of it, you're going to have 1, 2, 3 problems that are related to uniform probability that we're going to learn here in just a few minutes. Below it, you have 3 problems, 1, 2, gotta go to the next page, 3 that are related to normal probability, which we just got introduced to in, last week, and we had it on the quiz last week. Okay, but we didn't have Excel, just solving it manually. Where we're heading before week 2, though, is doing this normal probability equation just like the quiz, but we're heading to where we're gonna have a real sample size. Not just one, but a number there for sample size, which will change this equation. Instead of this denominator being standard deviation, this is called standard error. Standard error. So now, let's talk about the quiz problem where this was our first quiz problem about normal probability right there. We took 26, because we were being asked the probability for 26 or more, minus the mean, the given mean was 27.4, divided by the standard deviation, which was given at 5.2. And then the sample size was 1, so we didn't need to do this part, just divide by 5.2. We all figured out how to do that manually. Now, using Excel is very similar. Here are the 2 possibilities of using Excel for normal probability. Norm dot distribution and 1 minus norm dot distribution. You don't have to use the dot. You can write this equation without the dot, and it'll still work. Same thing. Just don't get confused with norm S or norm INV. The numbers in the parentheses, the first number is that number you're being asked the probability of. Number being asked the probability of. So in this case, in this problem that we had on our quiz up here, equals, first of all, I almost forgot. This top one, normal distribution, is if you're being asked about the probability of a number or less. It's going to the left. This bottom one, 1 minus normal distribution, this is if you're being asked the probability of some number or more. Normal probability is used with continuous data. Are you ready? 1, 1.001, 1.002, 1.003, whatever. I'm going on a number line here. Click, 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 and it keeps going like that. Notice we have numbers to the right of the decimal. That's continuous data. These are the 3 equations we're going to use with continuous data this semester. Uniform distribution, normal distribution, and exponential distribution. We're holding off learning exponential till later in the semester because a lot of people find that hard. But today's all about normal and uniform, and it's being used with this kind of data. Now, with uniform and normal problems, you're always being asked about a number or less or a number or more. You're never being asked for an exact number. It will never say, let me go back to the quiz problem. Hang on. See how this says 26 or more? What's the probability of 26 or more? It will never say, what's the probability of 26? Because if it's normal or uniform or exponential, that's impossible. Let me explain why. I mean, when you think about a bell curve, let's say the mean's over here somewhere, I don't know. You can't find the probability of just one number because there's so many numbers between the numbers. Don't forget, this represents 100%. If I said to you, what's the probability of 1.00, I'm asking for 1.00000052. Where's that going to fall? I mean, that's going to fall maybe between these two, but where between these two? And then what's right next to it? Well, there's 1.000051, and there's 1.00. There is infinity numbers between each of these dashes. There's so many numbers with continuous data that it's near impossible to find the probability of just one number all by itself. So that's why all questions related to these 3, uniform, normal, and exponential, will always be about a number or more or a number or less. The words, though, could be weird. Hey, what's the probability of at least 26? That's the same as 26 or more, but I said at least 26. What's the probability of no more than 26? That's the same as 26 or less, but I said no more than 26. So you got to watch the words, but with these three, uniform, normal, and exponential, it will always be a number or more or a number or less, depending, the wording could be any way, but it will never be an exact number. So is everybody with me? If it were asking for an exact number, your answer should be so close to 0, you might as well call it 0% chance. Because there's so many numbers to the left and right. To get a probability of just one number with continuous data, there's so many numbers between these two dashes. There's no way to find the probability of just one of them. There's an infinity numbers between those two dashes. That's how many numbers there are. So that's continuous data. That's what we're talking about right now. All right, so now, with that being said is, when you use normal probability, or we're not using uniform with Excel, or exponential, you'll always have a 1 on the end. Because every problem with normal and exponential is going to be some number or more, some number or less. So we always will have a 1 on the end. That's a gimme. There's some free quarter point right there. Now, you use the 1 minus in front if it's a number or more. If it's going to the right on the number line, you've got to put the 1 minus in front. You ready? You have to use that 1 minus in front if the question's about a number or more, if it's going to the right on the number line. In this case, 26 or more. What's the probability from a z-chart for 26 or more? You know it's going to the right, so you've got to use this 1 minus in front.
How about if it's less?
If it's less, you're going to use no 1 minus in front, the top equation. All right, let me repeat that. If this would have said 26 or less, we're using that top equation without the 1 minus. But because it says 26 or more, we're using the bottom equation with the 1 minus in front.
Are we going to find this one from that equation, like how we did in the quiz?
In binomial? This is just like binomial distribution, except you don't use the opposite for the first number with continuous data. So with exponential, with normal probability, you never have to change that first number. It's only when you're using discrete data equations, which are the binomial we learned already, and the Poisson that's coming in a couple of weeks. Let me repeat that. You ready? Remember how on the quiz you had to use the opposite number in front if you're using 1 minus in front here? That first number's got to be the opposite of what's being asked for. I think the quiz said 3 or more, you need to use a 2 here. That's only with binomial and Poisson. With normal and exponential, that number's whatever you're being asked for. It doesn't matter if you've got a 1 minus in front or not. That's the number you're being asked about. You don't have to use the opposite. Whatever that number is being asked about. So, help me out here now. We look at this quiz question. A set of data has a mean of 27.4, a standard deviation of 5.2. Calculate the z for the following number given the probability on a z-chart for 26 or more. My question is, do I use the top equation or the bottom equation? Bottom. Here we go. 1 minus N-O-R-M-D-I-S-T. I didn't even use the dot this time. It's still going to work. Don't worry about it. Parentheses. What you just heard me lecture on, this is not binomial, this is not Poisson, this is normal distribution probability. So what number would be that first number? 26. You don't need to use the opposite, even though this is a more than, because this is continuous data. So you're going to use exactly what you're being asked. 26. What would be the second number for this quiz problem?
27.4.
Very good, 27.4, because that's the given mean. What would be the third number? 5.2, 2 or 4? 5.2, but be careful. When we get a couple weeks from now, that's going to be 5.2 over the square root of whatever the sample size in that problem is. There'll give you a couple words added to it, and the sample size was. Those words are going to be added in a couple weeks to a problem just like this. And the sample size was. That needs to be divided by the square root. You're going to learn that SQRT is the Excel function for square root. And you'll put parentheses, whatever that sample size number is, right underneath there. That's in a couple weeks. Hang on. For the homework, just forget what I said. Comma. What's the last number in the parentheses?
1.
1. You just solve this. Let's see if, let's check it. First of all, what's our answer? 60.6064. But don't forget the Z-chart rounds. So when we use Excel, it's more exact. So we're gonna get something really close to 0.6064, but it's not gonna be that exact answer.
Did you turn on the
I did turn on the camera, thank you. I did, I luckily remembered. Is it still running?
Uh-huh.
Okay, cool. All right, here we go. So I'm gonna get my Z, here we go. Let me just get annual Z chart here. Here we go, here's the example. Here's the example, how to use this. It says, put your X that you're being asked about, first number, put the mean, put the standard deviation, and put a 1. So I'm gonna put it right here, off to the side, equals 1 minus NORM. Should I put a dot?
No.
I heard no first. So DIST, there it is, parenthesis. You said the first number is 26, comma. The second number you said is 20. Huh? What did I do wrong? Okay, 27.4, thank you. Comma, 5.2 you said?
Yes.
Comma, 1?
Yes.
Okay, if I did it right, this should be close to 0.6064, I think, or something like that. 6061. This is more exact. It doesn't round. The Z-chart rounds. Matter of fact, we had to round 0.26 something to 27 to look at the Z-chart. But you see, it's close, but this is more exact. Does everybody think? I want to make sure we get this. I want to try another one. Let me think. Where do I have another one at? I'm going to make one up. Same problem though. Let me get the quiz back up here.
Wait, isn't it the second one, the one minus?
Yeah, I used the second one. Hang on,
Use the first one.
hang on. Why did I use the 1 minus? Because the questions were 26 or
No,
more.
not on there, you used like the first one.
Which one you
just
talking
left
about?
it in as
Oh,
one.
I just got it lined up at the wrong spot, that's all. Hang on. Here, let me copy and paste. Hang on, here. Okay, there, is that better? Hang on. Is that better? Okay, there we go. All right, now, let's try another one. I'm going up here, I'm not trying to line it up with anything. The mean, I gotta get the quiz back up. I wanna make sure we got the right mean. Okay, the mean is 27.4. The standard deviation is 5.2. What's the probability the next one we pull out of the sample is gonna be 24 or less? No, 24.2 or less. 24.2 or less. We're writing this up in Excel. Help me get started. Ali, you're gonna help me? You ready? Help me get started, Ali. Am I using the top one or the bottom one for this 24.2 or less?
Top.
You guys are helping them. Just say the top one. Here we go. Equals NORMDIST parentheses. Everybody's involved now.
24.2.
What? Huh? She's saying whatever the question's being asked about, which happens to be 24.2 or less, is what that first number is. 24.2. Now what's the second number? 27.4, because the mean hasn't changed. What's the third number? 5.2, because the standard deviation hasn't changed. And always, what's the last number?
1.
1 when we're using normal distribution. Always a 1. And that's it. That's how you write it up. And now, if you're writing a test or on the homework, you're going to write it just like this, and then enter it into Excel and get a result. But I want to show you something on the homework. Hang on, let me show you this. Okay, there's 3 of these on the homework. Wait, where are they? 1, 2, 3. The first one says, no, that's not the first one. First one says, are you ready? This is your homework, so be prepared, get your mindset, think about what you gotta use, which one up here as I read this. If the mean is 22 ounces, the standard deviation is 4.2 ounces. Show your detailed work, manually calculating the probability of 20.5 ounces or less. I'm asking you to use this equation without the sample size. Use that equation to manually find what your Z is. Then, pull the Z chart out, look up your Z, round it to 2 digits to the right on here. Am I telling you which Z chart to use? Yeah, you don't even have to tell me if you're using positive or negative. Get the Z chart out, look it up, put that answer. Now this says 20.5 ounces or less, so you don't have to subtract from 1. You looked up the Z that you just calculated, you wrote the probability down, you're done solving it manually. Now it says, then give the Excel norm DIST. You can put a dot there if you want. I have it norm dist, but you can put a dot in the middle if you want. Function equation and result that you would enter into a spreadsheet. So you're putting both manually and Excel. And let me give you a hint. enter the Excel equation into the spreadsheet, because the answer for the Excel equation and the answer you're getting off the Z-chart will not be the same. So if you just grab the answer you just gave manually and put it for the Excel equation, I'm gonna know you never really entered it into an Excel spreadsheet, because the answer is not gonna be the same. There's gonna be slightly different, because Excel is more exact and the Z-chart's an estimate. All right? So you got both of those for that one. Now go to the next one. Now, use the same mean above, the 22 ounces. Use the same standard deviation, 4.2 ounces. From the previous question, show your detailed work calculating the probability manually for 20 ounces or more. 20 ounces or more, we're manually calculating now. You're gonna calculate a Z. You're gonna go to the Z chart, look it up, but then you have that one extra step, because it says 20 ounces or more. So you've got to subtract from 1. Whatever you're looking up on the Z chart for that problem, you've got to show that you subtract it from 1, because it's 20 ounces or more.
Manually, it's the same
Manually.
as before.
Hang on, the second problem you're solving manually, then it says to solve using Excel after you solve it manually again.
But the manually part is the same thing as what we used to do. There's no difference.
The manual part's the same as the quiz, same as this right here, same as the problem before, but leave enough room to give the Excel equation underneath it. So after you get your answer, you're gonna find Z, you're gonna look at the Z chart, whatever you looked up, you wrote down, but then you're subtracting it from 1, because you gotta find the opposite, because this is a more than question. Now you're gonna write your Excel equation, you're gonna use the 1 minus on this one, because this is a more than question. Everybody with me? And then plug it in and get a result, which is gonna be slightly different than the one you got off the Z chart. Now, here's where everybody's confused. This last question is not asking you to solve it manually. It's asking you to use Excel only on this last one. Let me read it. If the mean's 254 and the standard deviation is 11, give the Excel norm disk function equation end result to calculate the probability for 266 or less. Write the equation like you would enter it into a cell on a spreadsheet and solve this problem. This one you do not have to show manually, just Excel. So there's 3 of them there. How do we feel? Can we do those 3 problems? Everybody know what's expected? Yes, 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 yes.
With Excel, is it gonna give us our final answer, or do we still have to go to the Z chart after?
No, with Excel, it gives you your final answer. You don't use the Z chart at all.
Okay.
Yeah, and it's gonna be slightly different than what the Z chart gave you when you did it manually on those first 2 problems of Z. Who else had a question? Yes?
The second question, you do the sample size?
No, there's no sample size on that second question. There's no sample size on any of these yet. So right now, let me get this out of here. I don't want anybody. Right now, we're still not using sample size. We're assuming sample size is a 1. The square root of 1 is 1. And the standard deviation divided by 1 is the standard deviation. All right. Now, for the second half, yes, please.
Just for the difference between the Excel and Z chart, it'll only be like a couple decimals.
Yeah, oh, it's probably not until the 3rd or 4th decimal to the right anyway.
Okay, so you know you're in the right ballpark.
Mm-hmm. They're gonna be really close to each other. I may have accidentally made one exact and didn't even know it. But assume they're not gonna be the same.
We should put this out and work out and have this up.
Can you put the work on there and hand it in right on this? Yeah, absolutely. You're talking about handwriting, or even type it out. As long as it's not late, you can type out all your answers, sure. Yeah. Okay, you ready for the second half? How we doing? We got an in-class today. Everybody know we have an in-class today? What? What? Well, something like this, yeah. Sure. Isn't that how the in-classes always go? It's all, yeah, listen, the in-class is about learning from each other, you guys. All right, it's all about learning from each other, not just me. All right? All right, uniform. You ready? You have 3 problems on your homework related to the uniform probability. I'm trying to simplify this uniform distribution equation as much as possible, so I'm breaking it down like this. The story is going to tell you about a range of numbers. All right? The story is going to tell you about a range of numbers. And then it's going to ask you for the probability of a different range of numbers within that range of numbers. Are you ready? And here's the deal. How do you recognize a uniform question? It's going to describe the data as either being uniformly distributed or evenly distributed. Let me tell you these 2 words again. These are the 2 words that one of them you'll recognize and you'll say, oh, this is a uniform distribution problem. It will say the data is uniformly distributed or evenly distributed. One of those 2 words. It means this is a uniform problem. All right?
It was either uniformly or what?
Or evenly. Evenly. So let me see what we got here. Do I have something here? Okay, here's an example. Slater customers are charged for the amount of salad they take. Sampling suggests that the amount of salad taken is uniformly distributed between 5 and 15 ounces. Everybody see that? I'm going to read it again. Sample suggests that the amount of salad taken is evenly distributed between 5 and 15 ounces. Means the same thing. Uniformly distributed or evenly distributed. Hey guys, give me, I only need a few more minutes. So here's what you're gonna do. You grab the largest and the smallest number out of that sentence, and you subtract them and put them under 1. And that's called your density function. That's the most important calculation to start with. Let me repeat it. 1 over the largest number minus the smallest number in the denominator. 1 over the range of the full uniform distribution. That's your density function, that's your first step. Now you're gonna multiply that density function times whatever the range is of the question you're being asked about. The range of the question is multiplied by that density function. There's your probability, it's that easy. The tricky part is recognizing exactly what that range is of the question. Let me give you an example, you ready? The whole thing is between 5 and 15 ounces. What would the range be if I said, what's the probability the next salad coming up is 7 ounces or less? What would be the range then of the question, 7 ounces or less? What would be the two numbers I have to subtract here to find the difference between that range? 7 and what? No. No.
How did we get 7?
The question says, what's the probability the next salad is going to be 7 ounces or less?
7 minus 1?
Not 7 minus 1. Not 7 minus 15.
7 minus 0.
It's not 7 minus 0.
Mine's
What's the lowest number in our uniform distribution?
7 minus 5?
There it is. 7 minus 5. What's our density function? 1 over,
15 minus 5 minus 5.
there it is. That would be the same as 1 over 10. Times the question, 7 or less. 7 minus 5 is 2. 2 over 10 equals 20%. You see how I got that? Let's do it again. It's that easy. You ready? We're gonna do it again. Slater's customers are charged for the amount of salad they take. Sampling suggests that the amount of salad is uniformly distributed between 5 and 15 ounces. I can stop there. Think about your density function. You have enough information for the density function. 1 over the range of the full distribution. What's the probability the next salad is going to be 10 ounces or more? 10 ounces or more. Hang on. What's our density function? 1 over 10, which is 15 minus 5. There's our density function. But the question was, what's the probability the next salad is going to be 10 ounces or more? What are the numbers in this range right here?
10 minus 5?
Not 10 minus 5, 10 ounces or more.
Plus.
15.
Not plus, 10 ounces, I heard it.
15 minus 10?
15 minus 10 is the range, because 10 ounces or more can only go as high as 15, because 5 to 15. So 15 minus 10 is the range of being asked about, 10 ounces or more. So let's calculate this. This would be 1/10 over 15 minus 10, that's 5 over 10 equals 0.50. 50% chance the next salad is going to be 10 ounces or more, because it's exactly half of the full distribution. That makes sense. I want to make sure you get this. A die from Las Vegas gambling, one single die has 6 sides on it, numbered 1, 2, 3, 4, 5, 6. It's uniformly distributed, it's evenly weighted, it's evenly, each number has the same probability. I'm about to roll it. What's the probability I roll a 1?
How many sides is that?
Come on. It's a normal die. How many? What's the probability I'm going to roll a 1? 1/6. Because there's only 6 possibilities. That's the same as this uniform distribution. 1, however many possibilities there are. 15, the whole range is 15 minus 5. You get it? All right, the whole range. So here we go. Are you ready? Now this is going to get tricky. We have the salads, his sampling test says that the salads weigh evenly between 5 and 15 ounces. What's the probability the next salad's gonna weigh between 7 and 10 ounces? 7 and 10 ounces. What's that probability? What's our density function? 1 over what?
10.
1/10, which is because it's 15 minus 5. That has not changed. But what's the range of the question? This gets multiplied by what?
10 minus 7.
There it is, 10 minus 7, because I said, what's the probability between 7 and 10? There you go. And sure enough, I take this 10 minus 7, and this equals 3 over 10 when I multiply it, which equals 30%. Tell me you guys can do uniform distributions. They're that easy. They're that easy. Now I want to change it up, okay? Go ahead.
Could you say your last example one more time?
You ready? The question said, hey, we know from sampling that salads weigh, are evenly distributed between 5 and 15 ounces. There's our density function, between 5 and 15 ounces. What's the probability the next salad's gonna weigh between 7 and 10 ounces? The question was about 7 and 10, that's why we took 10 minus 7. We gotta find the range of what's being asked. Where most people fall apart on this question is if I would have asked that question 7 or less, they would have accidentally took 7 minus 1 or 7 minus 0 instead of 7 minus 5, because you can't go below the lowest number. You can't go above the highest number. And if I would have asked this question, what's the probability for 10 or more? Where's 10 or more? Right here. 10 or more, it can only go as high as 15. So people would have been staring at this for a while going, 10 or more, why do I know the range of what's being asked about? Because it can only go as high as 15. So the more than the less than can only go as high or as low as the range of the uniform distribution. And then if the question's asking for a range within the highest and lowest number, it's real easy, just subtract the two numbers being asked.
Now, I know you're putting your like final answer as a decimal, would you accept it as a percentage?
Absolutely, absolutely. Move the decimal 2 places, add the percent symbol. Go for it if you
You
want.
accept it either way?
I'll accept it either way, 0.30 or 30%. Either way, I'm so happy you got the right answer. Go ahead.
So for this, the one or more, or whatever, we always gonna minus 5 the number we got, like in the first part, like 15 minus 5.
Right here, yeah, the numbers given in the problem. I'm gonna state another one to you right now. We have a distribution that is uniformly distributed, and it's between 120, no, that's too big of a number. 12, and 5. There we go, 12 and 5. There it is. What's the probability the next one of these things that come are gonna be 6 or less? Okay, help me calculate this. What's the probability for 6 or less? Start with the density function. 1 over what?
7.
Why?
Because
minus
of
5.
12 minus
12 minus 5, very good. 12 minus 5 is 1 over 7. What's the question being asked for? What's the range of the question being asked for?
6 minus 5?
6 minus 5, because as low as you can get is 5. So 1/7 over 6 minus 5 makes 1 over 7. So this equals 1/7, whatever that turns into. 0 point, I don't know, what's 1 divided by 7? 1/13?
0.14.
0.14? Are you rounding? Come on, we gotta go 4 digits.
0.142.
1, 4, what?
1.1428.
1443?
It's 1.1.
Yeah,
1.7.
143. Yeah, 143.
1.143 because we rounded, it was 2.
Yeah, but what's the next digit? We gotta.
Okay,
No,
no,
eight.
0.14285.
There we go, thank you very much. 0.14285, we gotta go 4 digits, you guys, you gotta get in the habit. I don't want you to lose, I'm gonna be more strict on this 4 digits on quiz 2 and quiz 3. I wanna tell you why. We're coming up on quiz 3 where there's a whole bunch of problems where the first 2 digits to the right of the decimal are zeros. So if you stick around, we're gonna there's no answer there. So we gotta get used to 4 digits to the right.
Can you do it with 1?
At least 4 digits to the right.
How is it 695?
6.5 because the question said 6 or less, and 5 is as low as it can go.
How about it says or more?
What if this was 6 or more? 6 or more, ready? Hang on, let me put it up here. 6 or more. What's the density function? 1 over
7.
12 minus 5, which is 7, times
12
6 or
minus-
more.
12 minus 6?
There it is, 12 minus 6, because as high as it can go is a 12. As high as it can go is a 12, so 6 or more would be 12. So that's 6 over 7, whatever that turns out to be. There it is. All right, are we ready? Yes.
What if it says between? What if it says between?
Ready? Let's do one between. Don't forget, uniform distributions between 12 and 5. So the density function is 1/7 again. Are you ready? The question is, what's the probability the next one would be between, hang on, between 7 and 9? Between 7 and 9. So 1/7 times
9 minus 7.
9 minus 7. That easy.
But
Nine.
wouldn't,
Both 9 and 7 are within the range of 12 and 5, so just 9 minus 7, the
but
bigger.
between 7 and 9, wouldn't it not include 7 and 9?
I don't know how to word it to include it, but I meant to include it.
Okay,
I don't know how to word it to include it. Hang on, let me see.
but technically between would not include that 7.
No, I think it does include it.
You think it does?
Yeah,
But it's between.
yeah, including them. Well, we had a homework problem that we had that same situation. We had to figure out whether, remember it was like getting a C or better or C or worse. Remember that whole thing? I can't
But
remember.
C or better like includes.
No, it wasn't C or better. It was getting between a B and a D. I think it was, and we had to decide whether it included B and D. It did.
But will you specify like between including?
I don't know. I can't remember. I would say included. I've never had it being confused before, so hopefully however it's worded on the next quiz won't be confusing.
Do you want us to convert it to a percentage, or do you want to keep it?
It's up to you.
Oh.
Most people will leave it at decimal and not attempt to move that decimal 2 places to the right and add the percent symbol, because they don't wanna lose points, but so it's up to you though. Now, I wanna point out something, hang on, where is it? Look at these 3 homework problems. I wanna start with the first one. A random variable, how much time we have here? We're running late. A random variable x follows a continuous uniform distribution with a lower bound of 15 and upper bound of 42. What's the height of the density function? This problem's asking for the density function only. That's it. You don't have to do the whole thing, just the density function. Now, go to number 2. If a customer's salad are between 2.8 and 9.2 ounces, uniformly distributed, use the formula to manually calculate, showing your detailed work, the probability the next salad will be 5.6 ounces or less. There's that one. Now let's go to the next one. If a random variable x is known to be evenly distributed between 33 and 75, manually calculate, showing your detailed work, the probability that x having a value between 52 and 66. These are almost too easy. You got them done in your head right now. If you attack them right after class, this homework will be over with. Yes?
The first question is just asking for you to put
Just the density function on the first one, then the next 2 are full blown out density function times something, and give me the answer. All right, ready for the in-class?
Yeah.
Let's do it. Let's do it. Don't forget, help others when you get done. Walk around the room from other rows especially. If a random variable x is known to be uniformly distributed between 72 and 55, manually calculate, showing your detailed work, the probability of x having a value between 64 and 70. God, that almost looks like exactly like a homework problem, doesn't it? Hang on, I gotta stop the video.